Hello, fellow Pre-Calc students. To start correcting this number 16, I'm going to refer to the formula of a tan graph, which is y equals d plus a tangent of bx minus c. Now, we look at the equation that was given to us, which is y equals tan of x over 3, and we see that there's not any d or a component to it, and there's no c either. So we're really just dealing with y equals bx. So what we want to do is factor out this x over 3 so that it looks like y equals tangent of 1/3 x. I'm going to erase all of this so that things are a little bit clearer and we can focus on what we're doing. Awesome. I don't know what that y is there for. Okay. To find the period of tangent, which is usually simply pi, is usually just the period, but now b over here, 1/3, changes our period. And we remember that since it's before the x, it flips because x is weird like that. So instead of being 1/3 pi, it's going to be 3 pi. And that is going to be our period over here. Okay. When we crossed out c, we realized that there was no phase shift because the c part of the equation that I showed you at the beginning is what tells you if there is or is not a phase shift. And since we did not have a c, we don't have a phase shift. Or maybe it was a, yeah, it was a c. Yeah, it was a c. Okay, the asymptotes, usually, here, let me make this bigger. I'm going to erase this because I hope you understand that, or you can erase it and go over it again. Or rewind, not erase. Okay, for the asymptotes, well, okay, let's just graph this with 3 pi, and then I'll explain the asymptotes. Okay, so since there was no phase shift to the left or the right, this sine or tangent function still, the middle of it is still right here at the origin. Oh no, what's happened? Oh my gosh, I don't know what I did. Okay, are we good? Why is my pen so small? What's about this? Okay. Okay, it should be bigger now. It's still here at the origin. It is still the center of this tan graph, and we want it to cover 3 pi. So if this right here is going to be pi over 2, and this is negative pi over 2, we want to make sure that our graph covers this right here is 1 pi, 2 pi, and to be even, 3 pi. So our graph is going to be between those points, which is going to put our asymptotes right here and right here. And then we draw in our beautiful tan graph, which is, I'm going to try, oh no, I'm going to try and make really nicely. Ooh, that's not very good. You can do better than that. Okay, we're going to try that one more time. Nice, smooth lines here. Oh my gosh, I hate this iPad. Okay. And I have this is kind of like that. And that's going to be kind of like that. Okay, well you get the idea. You all know what a tan graph looks like. Anyway, so write down the equation for our asymptotes. We're going to go to, it would usually be pi over 2 plus pi, n pi. Is that right? Okay, it's usually pi over 2 plus n pi. But our period is different, obviously, so we're not starting our asymptotes at pi over 2, which would be right here. We're starting them here at, what is that? 3 pi over 2, obviously. We're starting them there at 3 pi over 2, and we're not doing them every pi, which would be that length. We're doing it every 3 pi, so our next one would not be until here. So we want to edit that to be a 3. So your asymptotal equation comes out to be 3 pi over 2 plus 3n pi. And to finish this graph, we're going to go right in the... Oh, that's wrong. Okay. Oh no, erase that. In the middle, that would go to here of this. So our next equation would be right there. Pretend to draw another tan graph. And that's your number 16. Have a great day.